Hello, today we're going to continue talking about triangles, but we're going to be focused specifically now on the angles. At the end of the last lesson, we talked about how the interior angles, which are measured in red here, are the inside angles of a triangle. And we know that the three interior angles add up to 180 degrees. Each triangle also has exterior angles, which are easier to see if you extend each side length a little bit past where it would normally go. So these three blue marked angles are exterior angles. Sometimes we use exterior angles to help us prove things or find missing angles of the inside or interior of a triangle. One important theorem that we already used, we just didn't call it the theorem last time, is triangle sum theorem, which says that the sum of the measures of the interior angles add up to 180. So measure of angle A plus measure of angle B plus measure of angle C equals 180. We actually used that a little bit in the last lesson. We just hadn't talked about the theorem yet. Sometimes, which we will see more and more doing proofs, there will be what's called an auxiliary line, which is this blue line here, that's been drawn into the diagram to help find missing angle measures. Here, because the auxiliary line BD is parallel to the line segment AC, we can use special relationships that we know about lines, parallel lines, and transversals. So that's the whole point of using that. Notice that it's not quite going to be the same thing as an exterior angle, but it can help us find some of these missing angles. Just something to watch out for. We also have a theorem dealing with exterior angles. The exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So here I have angle 1, which is an exterior angle. Whatever angle 1 is, measure-wise, is going to be the measure of angle A plus the measure of angle B added together. This comes from the fact that a triangle's three interior angles add up to 180, and that a linear pair adds up to 180. So this angle right here next to angle 1 is part of both of those. So if I were to basically solve that system of equations, we would find that that would make angle 1 equal to these two added together. What we're going to be doing today is finding interior and or exterior angles of triangles. So these ones look a little more complicated because they have some x's and things like that. Make sure that you don't just stop and find x, you find the exact thing they're asking for. So number one, or I guess they're not numbered, this first problem here wants us to find the measure of JKM. So JKM is the exterior angle right here. That's what we are after. We know that this exterior angle here is going to equal the sum of these two non-adjacent interior angles. So measure of angle JKM, which we know is 2x minus 5, is going to equal these two added together, x plus 70. From here, this looks like a basic equation that we can solve. We've been doing things like this off and on all year, so let's do that. Let's get our x's on the same side of the equation by subtracting x. 2x minus x is just x. Get our numbers on the same side of the equation, undo minus 5 by adding 5. And we get that x equals 75. You might be tempted to stop there. Remember, they're not asking us for x. They're asking us for the measure of JKM. So what I need to do is I need to take this x and plug it in here to find the measure of JKM. So measure of angle JKM is going to be 2. And since instead of x, we know x is 75, so parentheses 75, sub that in right there, minus 5. And then we simplify that. 2 times 75 is 150, minus 5 gives us 145. So measure of JKM is 145 degrees. The math would still check out since x is 75 plus 70, 75 plus 70 is 145, just like we expected. Let's try one more like that. So this time we are after measure of angle PQS. So PQS, that is this angle right here, the exterior angle. We know that the exterior angle PQS, 3x plus 25, is going to equal the two non-adjacent interior angles added together. So 2x plus 65. Once again, solve the equation. So start by getting your x's on the same side. I'm going to choose to do that by subtracting 2x from both sides. 3x minus 2x is x. Get your numbers on the same side. To undo plus 25, I subtract 25 from both sides, and we get x equals 40. We're not done. We know that what x is, but we still need to find PQS. So we're going to take the x equals 40 and plug it into x right here, since PQS is 3x plus 25. So measure angle PQS is 3. Instead of x, we're going to sub in that 40, because x equals 40, plus 25. 3 times 40 is 120, plus 25 gives us 145. It's just a coincidence that we got the same angle measure both times. So then the measure of angle PQS is 145. New vocabulary for us. A corollary to a theorem is a statement that can be proved easily by using the theorem, so that we often say the corollary follows from another theorem. So our triangle sum theorem said that the three interior angles of a triangle added to 180. This corollary says that the acute angles of a right triangle, so the two not right angles, have to be complementary or add up to 90, which makes sense. A whole triangle, three angles add up to 180. If 90 of them are taken up by the right angle, that means the other two angles have to account for the other 90 degrees. So now we're going to be looking at some right triangles. They want us to find the measure of each acute angle. So once again, we're not finding x as our final answer. We're finding x and then using that to find the measures of each acute angle. So we know that since this is a right triangle, that the two other angles are going to be complementary or add up to 90. So we can say 2x plus x minus 6 equals 90, and then solve that equation. Combine your same side like terms. 2x plus x is 3x. Get your numbers on the same side by adding 6 to both sides. And then get x completely by itself by dividing both sides by 3. You get x equals 32. We're not done yet. We need to take that 32 and plug it in to each of these to find the measures of each angle. So 2x is going to be 2 times 32, which is 64 degrees. So one of our angles is 64 degrees. The other one, x minus 6, x is 32, so it's going to be 32 minus 6 is 26 degrees. And if you double check and add those together, 64 plus 26 does add up to 90, so the math all checks out. Let's try one more of these. So once again, it's a right triangle. We know that the other two angles, the two acute angles, have to add up to 90. So one of them is 6x plus 7. The other one is 11x plus 2. If we add all that together, we end up with 90. Combine your same side like terms. 6x plus 11x is 17x. 7 minus 2 is 5. And then keep solving from there. Undo plus 5 by subtracting 5 from both sides. And then divide both sides by 17. We get x equals 5. We're not done yet, though, because remember, we want the measures of the angles, not just what x is. So we need to plug x equals 5 in here and x equals 5 in here. So let's start with that top angle. 6x plus 7 is really going to be 6 times 5 plus 7. 6 times 5 is 30, plus 7 is 37 degrees. So one of the angles is 37 degrees. The other one is 11x minus 2. But since x is 5, I'm going to plug that in to the x spot. 11 times 5 is 55, minus 2 is 53. So my two angles are 37 degrees and 53 degrees. If you add those together, it equals 90, which is what we were expecting. The last things we're going to do are more word problem based. There's no pictures. If you want to draw the pictures, you can. They're going to be talking about right triangles. And it's similar to something we did back with complementary and supplementary angles several weeks ago. Let's take a look at the first one, draw a picture. The pictures are optional, but if they help you, go for it. And then find the measure of each acute angle. So let's give this a try. The measure of one acute angle of a right triangle is 1.5 times the measure of the other acute angle. So we have a right triangle. And your picture does not have to be very good. You can see mine's not too great. We have one acute angle. We don't know the measure of that, so we'll just call it x. The other one is 1.5 times the measure of the other acute angle. So the other one is 1.5 times whatever the other one is. The other one is x, so this is going to be 1.5x. They want us to find the measure of each acute angle, which is what we did back here. So one angle is x, the other angle is 1.5x. Since it's a right triangle, we know that these two acute angles need to add up to 90, just like we did back here. They just didn't give us a pretty picture. And now we solve this. 1x is the same as x. 1 plus 1.5 gives us 2.5x. And then to get x completely by itself, I need to divide both sides by 2.5. And I end up with a x equaling 36 when I do that. Our two angles, just like before, we don't want to just find x, we want to find what the two angles are. One of the angles is just x, so one of them is 36 degrees. The other angle is 1.5x, so it's going to be 1.5 times 36, which gives us 54 degrees. So it's really the same thing we were doing in the problems before this, except for you need to basically be able to sift through the problem if it helps you draw a picture, but more importantly, solve this equation and then plug those values back in for x. Let's try one more. The measure of one acute angle of a right triangle is 3 times the sum of the measure of the other acute angle and 8. This one's a little more complicated. So I'm going to draw a picture here. Work with me, pretend like that looks like a really good right triangle. One acute angle, we'll just call that x. The other acute angle is 3 times the sum, which means we add, the measure of the other acute angle and 8. So 3 times other acute angle and 8, sum would be 3 times x plus 8. We don't really need that times dot here, so this other angle we're just going to call 3 parentheses x plus 8. Wording there can get a little tricky. So then now we know that x and 3 parentheses x plus 8 need to add up to 90 since this is a right triangle. So then let's solve this out. We need to start by distributing the 3. 3 times x is 3x. 3 times 8 is 24. Add your same side like terms together. And then continue solving from there. Subtract 24 from both sides. And then divide by 4. You get a decimal when you do that, which is okay. Now I need to find the measure of each acute angle. One of them is x, so one of them is just 16.5 degrees. The other one is 3x plus 8, which is 3 times 16.5 plus 8. And you can do that by hand or in a calculator. Either way you go, you're going to get 73.5 degrees. We have one more problem we're going to look at. I'm going to do that in one additional video, so hang tight. But that problem is going to just combine doing things with interior and exterior angles.